So in these problems, we're going to keep proving identities. So for example, prove the identity 1 plus tangent squared x cotangent squared x equals cosecant squared x. So again, I usually try to start with the messier side. The messier side here is the left-hand side. So 1 plus the tangent squared x times the cotangent squared x. And you have to remember where we're trying to get to. So we're trying to get to cosecant squared x. So we want to kind of like get stuff down as much as we can. So the first thing that I'm going to want to do is remember that 1 plus tangent squared x, there's a Pythagorean identity that says that's the same as secant squared x. So this is going to become secant squared x cotangent squared x, and that's by the Pythagorean identity. So my problem looks a little bit better. It's a little less stuff, but it's still not where we want. So I've got this secant squared, I've got this cotangent squared, so I'm going to change both of these. I'm going to change these into sines and cosines. So we'll take care of the secant squared first. So I can replace secant squared by 1 over cosine squared x times cotangent squared x. And so all I did there was use a reciprocal identity. And now I can replace cotangent squared x with cosine squared x over sine squared x. And I just used a quotient identity. And then the cosine squared x's would cancel each other out, so I'd be left with 1 over sine squared x. And so all I've done here was some algebra. And then finally, 1 over sine squared x is in fact cosecant squared x. And I'm just using that reciprocal identity again. So we'll do another one here. Unfortunately, there's no one way to do these problems. So they just actually take some practice with getting them so that you feel confident with them. So for instance, cosine squared x minus sine squared x equals 1 minus 2 sine squared x. So again, I'm going to start with that left-hand side. So cosine squared x minus sine squared x. And if I look at where I'm trying to get to, I'm trying to get to a problem where the only trig function in it is sine squared, which means I'm going to have to get rid of this cosine squared. So let's use a Pythagorean identity to get rid of that cosine squared. So remember, sine squared x plus cosine squared x equals 1, which means that the cosine squared of x is equal to 1 minus the sine squared of x. So that's what I'm going to replace. So we're going to replace cosine squared x with 1 minus sine squared x minus another sine squared x. And so all I did there was the Pythagorean identity. And then minus sine squared x minus sine squared x, that means I have 2 of them. So this is 1 minus 2 sine squared x, which is exactly what we wanted to prove. So that's exciting. And all we did from step 1 there to step 2 is a little bit of algebra. So it's not too bad. So we'll try one more here. So I have secant x plus 1 times secant x minus 1 equals tangent squared x. Okay, so again, we're going to start with the left-hand side. So secant x plus 1 times secant x minus 1. Okay, so we eventually want to get to tangent squareds. And so we're going to want to use that Pythagorean identity to get from, we have some secants, so maybe we can try to use that tangent squared x is equal to secant squared x minus 1. But I'm not quite there yet. So this first thing I'm going to have to do is I'm actually going to have to FOIL these. So if I FOIL these, that's good. I'll end up with a secant squared. So that first part there gives us secant squared x. Oops. Then we need to multiply this times this times this, and that times that. So we're going to end up with a minus secant x, a plus secant x, and a minus 1. And all we did here was some algebra. So the minus secant x and the plus secant x cancel each other out. So we're at secant squared x minus 1. And again, that's just due to some algebra. And then finally, secant squared x minus 1, that's exactly what we have over here. So we know this whole thing is equal to tangent squared x, which is exactly what we were trying to prove. And that's because this is a Pythagorean identity.